Hello everybody, so my name is Anna Watson and this is my lesson presentation. Please bear with me, I am experiencing a little bit of like a cold or sinus infection or something and my voice keeps cutting in and out and coughing and all kinds of stuff, so just hang in there with me. So the central focus of my lesson, the students will be able to fully understand how two multiplication problems that have the same number will always result in the same answer. So this lesson needs full comprehension because students are going to build on this lesson for the rest of the unit and even units past this unit. Some requisite skills consist of interpreting products of whole numbers. So for example, interpret 5 times 7 is a total number of objects and 5 groups of 7 objects. And another requisite skill includes simple multiplication. That's important because we're pretty much just building on that now. So for our standard, it is interpret a multiplication equation as a comparison. So for example, interpret 35 equals 5 times 7 is a statement that 35 is 5 times as many as 7 and 7 times as many as 5. For our objectives, given examples in modeling, students will be able to compare different multiplication problems with the same digits and understand that they will result in the same product with 90% accuracy. The students will be able to compare 5 times 7, 7 times 5, and similar problems while getting the same answer to each. The students will be able to group these numbers accordingly to compare how numbers can create the same product. With much practice, the students will be able to exemplify 5 times 7, 7 times 5, and how they both equal 35. Sorry. So for a formative assessment, I'm going to ask the students during the lesson some questions just to check for understanding. As the students are completing the activities, I'm going to make rounds of the class, pen and paper. I'm just making notes of the students who are needing some extra practice and who are going above and beyond or are very knowledgeable of the subject. Students are going to be given 12 multiplication problems, so there's going to be 6 products but 12 equations. So as you can see, 35 equals 5 times 7 and 7 times 5. There's 2 equations, but they both have the same product, as the same for the rest of those. I'm going to provide whiteboards and group the students in pairs. So they're going to do think, pair, share, so they're going to think independently. Pair, so go over it together as a pair, and then share it with the class. So they're going to share it by writing their answer on whiteboards. So they're going to do think, pair, share for the first 6 equations or 3 sums, or products, and the last 6 will be done independently. For summative assessment, they're going to take a unit test at the end with 90% accuracy. Students who did not perform will be retaught in smaller groups or individually with the teacher in a way that best suits their needs, whatever they are. For accommodations and materials, obviously specific accommodations will be made for students that are 504 or SPED based on whatever their IEP states. Some accommodations include more time on that unit test, special seating, maybe closer to the teacher, closer to the board, maybe some shorter assignments, providing more one-on-one time, reducing difficulty, or adapting the assignments based on their needs. Since I don't have a class sitting in front of me, I can't tell you what their needs might be, but these are some of the accommodations that could be made for them. For materials, obviously pencil, paper, whiteboard markers, internet access, the counting bears, note card for exit ticket, projector, our YouTube Brain Break, Kahoot, and Khan Academy for extra practice. And that technology integration is going to be used not that often with this lesson just because it is mostly grouping, multiplication, counting, that kind of thing. They are going to use technology for the Brain Break, which is at the end, and to review with the Kahoot or Khan Academy activities. So for background, the key concept of this lesson is to compare 2 multiplication problems with the same numbers and understand that the answer will be the same. Along with the answer being the same, the students are going to have to group the numbers together and realize that the product of 35 is the same product as 7 groups of 5 or 5 groups of 7 or any similar problems. The academic language is multiply, compare, categorize, analyze, similarity, equation, pretty much anything that goes along with comparing these equations, multiplication, that kind of thing. This lesson is extension of multiplication, so it must be thoroughly understood before they can jump to grouping different numbers with different products. The students will use this knowledge learned in this lesson to build on future lessons in the unit. And I'm going to plan differentiated lessons and activities dependent on the different needs of students. So I'm going to definitely analyze my students' their learning styles, add on supplemental help and encouragement to the students who need it, and thoroughly address the needs of different students. I'm going to connect this lesson to things in the community. We'll get into that a little bit more later, specifically with things like cans, candy bars, trophies, that kind of stuff. So an example includes 6 cans is equal to 3 groups of 2 or 2 groups of 3. So for an introduction of the lesson, I'm going to definitely welcome the students, introduce the lesson by having 4 bell work problems. So once they get settled in their seats, we're going to have these 4 problems, which are 5 by 7, 6 times 4, 5 times 3, 2 times 9, and these problems are just going to help get their brains moving. I'm going to have 4 volunteers come to the board and write down the answers to these problems. I'm going to go over the answers with them and give them an example of 3 times 2 equals 6, 2 times 3 equals 6, and I'm just going to explain what our lesson is going to be going over, which is comparing numbers in an equation that have the same product. So I'm going to explain that the end goal is for students to understand the comparison of multiplication problems and how they correlate to the same product. For procedures, it's a pretty lengthy lesson, but I think it's a bunch of fun. I'm going to begin the lesson by asking 2 questions, which is why is the product of 35 equal to the equations 5 times 7 and 7 times 5. For the second question, how can we create an example of this rule? Again, I'm just going to use volunteers for this. If there's no volunteers, then I'm just going to call on students who look like they would know the answer, or just randomly throughout the class. I'm going to begin to write down problems on the board and explain how the product of 35 is equal to 5 times 7 and 7 times 5. I'm going to tell the students that any 2 multiplication problems with the same numbers on each side will always result in the same product or answer. I'm going to ask students to pull out a piece of paper. This is going to be for notes and to practice the I do, we do, you do exercise. So for the I do, I'm going to use the example of counting bears, and I'm going to begin to group the multiplication problems together. So I'm going to create 5 groups of 7 and 7 groups of 5, and that's going to be a visual representation of the product of 35. So for the we do, we're going to do 8 times 4, 4 times 8, which is where we're going to group 8 groups of 4, 4 groups of 8 with the counting bears, and then there's going to be the you do. So the students are going to do that one, which is 9 times 3 and 3 times 9. So they're going to write on their piece of notebook paper. This isn't going to be turned in, it's just going to be for practice only. After the examples are finished, I'm going to write 3 more examples so the students can see them large on the board, and we're going to begin the think, pair, share activity. Those are the 3 examples right there. 5 times 7, 7 times 5, 3 times 2, 2 times 3, 4 times 6, 6 times 4. Each student should independently think on this. This is going to be the think part. After a couple minutes of individual thought, they're going to be grouped into pairs, where they're going to do the pair. And each group is going to be provided the counting bears and a dry erase board and expo marker. The students are going to be instructed to turn their desks to face each other after they are in their said pairs. They're going to have 4 minutes per problem. I'm going to set a timer, so whenever each 4-minute timer goes off, the students are going to raise their whiteboard explaining their answer. So 35 equals 5 times 7, 7 times 5 is just an example. They should have some kind of example of how they grouped those, really just whatever comes to their mind, just so that they are grasping the concept. During this exercise, I'm going to be walking around making note of the students that are struggling, meeting expectation, and exceeding expectation. I'm also going to be popping into groups to make sure that they are on task, not talking about what they're going to be doing this weekend, what they did last night, what they're eating for lunch, making sure that they're really focusing on the problems and grouping them using the counting bears. I'm just going to make sure that they don't have any questions about the activity. So after each one of these exercises are finished, they're going to put up their expo marker, put up their board, put up their bears, and return them back to the learning station. And I'm going to call on groups of 3 at a time to do this so that they're all not running into each other or getting hurt. After the supplies are put up, I'm going to say if you can hear me, clap once. If you can hear me, clap twice. As many times as it takes for the students to put their attention on me. After that attention signal, they're going to be dismissed back to their desks and instructed to turn them the right way. So I'm going to instruct the students to pull out a piece of paper. On this piece of paper is going to be how they're going to express their mastery. So those last 6 equations, or it's going to be 3 products total, but 6 equations. They're going to do this quiz style, and then they are going to pass it up to the front when they are finished. On this paper, they should have some kind of example that represents 2 groups of 8, 8 groups of 2, and what the product is of the equation. Like I said, they're going to pass those to the front whenever everyone is finished. It's just a little fun activity to close off the procedure section. I have the example of 3 times 2, 2 times 3 equals 6. So we're going to do clapping just to kind of do a more kinesthetic learning style for these students. So you're going to clap 3 times, 2, 3, 1, 2, 3. So that is 2 groups of 3, which equals 6 claps. And you're going to do it the other way. So you're going to do 3 groups of 2. So 1, 2, 1, 2, 1, 2. That also equals 6 claps. That's just going to be an example of 3 groups of 2. So I'm going to do this example with the class again. I'm using a different problem, so 3 times 4, 4 times 3, which is going to equal 12. Just to save time for the presentation, I'm sure you can imagine and read along just how that would go. So I'm going to instruct the students to sit back in their desk, and we're going to move on to the closure, which is just going to lead to recapping what was taught for the day. So I'm going to close the lesson by asking the students if they have any questions, and also kind of recapping everything that's going on. And after that is finished, I'm going to go ahead and introduce the exit ticket. But right before the exit ticket, we're going to go ahead and just talk about these things as a class. Connecting the grouping of numbers and products to things you can find in your community, so stores, churches, homes, etc. That's where we talk about the 6 cans of food is equal to 3 groups of 2 or 2 groups of 3. That also can do the same with trophies in your house, in your school, in your church. That can be used with candy bars, Skittles, M&Ms, spoons, knives, just whatever you have that you can group. So they could really practice that with anything. And on their exit ticket, it's going to be written on a note card. They're just going to pass these up as they, or give them to me as we are finishing the class. And on there's going to be these 3 things. What did you like about the lesson? What did you not like about the lesson? And what did you learn? This is just going to give me an idea of what was beneficial to the students and what wasn't. Then we're just going to finish off the class with a brain break, which is just a fun little video on YouTube. Assessment evidence, like I said earlier, the formative assessment, just asking questions throughout the lesson and making sure that the students are really understanding what's going on. As they're completing activities, obviously making rounds, checking in with students individually, and writing down those students who I notice are struggling or who are doing exceptionally well. Also giving those 12 multiplication problems like everyone saw earlier. I'm just going to provide those whiteboards, having the think, pair, share time, and giving those counting bears to prove that equations are the same, and allowing them to raise those boards when it is time. So for summative assessment, just taking that unit test, and the students who don't perform well obviously are just going to be retaught in those smaller groups or individually with whatever best suits their needs. So for modifications, the teacher is going to use different teaching strategies. Obviously, I'm going to come to meet the needs of my students the best that I know how, whether if they're a kinesthetic, a visual, an auditory learner. I'm going to reteach any material that they don't comprehend. So this could consist of small group, individual, large group. I'm just going to meet the needs of the students in all ways that's possible. Reteaching will be based off the total comprehension of students. Students who did not master the lesson will use Kahoot or Khan Academy for additional practice at home or in class if time permits. For enrichment, the students are going to be given extra practice with more complex problems. So this could be an example of 8 times 9, 9 times 8. Those are much higher numbers, which are going to